Welcome to the SAR channel, where sound and audio are demystified. Telephone technology has come a long way, moving from simple wired analog systems to modern wired and wireless digital ones. It's amazing how dialing a few numbers can send your voice through complex networks to someone else with clear sound. The telephone system eventually became the foundation of the internet, which completely changed how information is shared. Today, whether it's a link between two computers or millions, nearby or across the world, digital audio plays an increasingly vital role in telecommunications. Modern telephone systems use digital transmission, which can also carry high-quality digital audio. Both analog and digital signals weaken over long distances, but while analog signals pick up noise, digital ones can be restored accurately. Today, phone companies mainly use electronic switching and fiber optic cables between exchanges. To them, every call is just data, so long-distance and local calls have the same sound quality. However, the connection from a user's home phone to the exchange is usually still analog. In the plain old telephone system, POTS, the lines provided by the phone company are called subscriber loops or central office lines, connecting users to central offices through analog lines. Trunk lines link users to a private branch exchange, PBX, where switching and routing occur. This system uses circuit switching, meaning a temporary continuous path is set up for the call. The audio range for normal phone calls is 300 Hz to 3400 Hz. Speech is encoded using 8-bit PCM at an 8 kHz sampling rate, producing a bit rate of 64 kilobits per second, with the bandwidth limited to 3.4 kHz. Techniques like amplitude companding are used to improve sound quality. Before the 1960s, analog calls were carried over copper wires, one pair per conversation, with thousands of pairs bundled together underground. To handle more calls, Bell Laboratories developed digital transmission and introduced the T-carrier system. Today, most long-distance calls use various T-carrier systems that send digital audio, video, and data through copper, optical fiber, microwave, or coaxial cables. Integrated Services. Digital Network, ISDN, is a type of dial-up phone service that allows two-way, full-duplex digital communication. It provides a digital link between the user and the telephone exchange, connecting further to long-distance digital networks. ISDN offers a total data rate of about 144 kilobits per second. Although it works over standard telephone lines, special equipment is required at both ends to send and receive data. In normal telephone systems, signals that control calls share the same channel as the communication itself. This is called in-band signaling, and it can briefly interrupt communication. ISDN avoids this problem by separating the user's data channels from the signaling channel, a setup known as out-of-band signaling. This ensures that the user's channels are dedicated and not disrupted by signaling data. While a simple telephone can be used for voice-only ISDN calls, sending digital audio requires extra devices like AD and DA converters, a codec, and an ISDN interface. A related service, Switched 56, offers a two-way data connection at 56 kilobits per second. Other commercial systems use T1 telephone lines to provide several full duplex digital audio channels for professional use. Companies spend billions on fiber optics, switches, and routers to create faster internet connections. But the biggest challenge remains the last mile, the link between the network and people's homes. Several cost-effective methods are used to solve this problem. ADSL, asymmetric digital subscriber line, delivers high-speed data along with normal phone service over a single pair of copper wires. Like ISDN, it requires two modems, one at home and one at the telephone office. But unlike ISDN, it works with the existing phone lines and numbers. ADSL uses a technology called DMT, discrete multitone, for encoding data. DMT splits the phone line's bandwidth into many small frequency channels and sends data through all of them at once. It also constantly checks the quality of each channel and adjusts how much data each carries to achieve the best speed. DMT is the standard method used in ADSL systems. In practice, ADSL often competes with cable modem services for high-speed internet access. Many different technologies have been created for cellular communication. One of the most common is GSM, Group Special Mobile, a time division multiple access TDMA system that started in Europe and is now used around the world. It uses frequency division duplexing, FDD, for both sending and receiving signals, and applies a modulation method called Gaussian minimum shift keying, GMSK. If you've enjoyed this video so far, please hit the subscribe button for more. Thank you. Today, thousands of networks connect millions of communication devices around the world. While most dedicated audio interfaces send continuous real-time data between 2 points, computer networks usually send data in small packets, not continuously, and connect many different types of devices. To work properly, networks must manage traffic to prevent conflicts. Unlike audio interfaces that use a specific audio format, networks can carry all kinds of data, such as email, images, audio, and video, using a shared file structure. Because network transfers depend on data rates and traffic levels, delivery is not always real-time and may be faster or slower. Some networks can reserve part of their bandwidth for real-time activities like video conferencing. Network transfers are now replacing the old practice of physically carrying files, sometimes called the sneaker net. Networks can be built in several ways. In a bus network, all nodes share a single line. In a ring network, they connect in a closed loop, and in a star network, each node connects directly to a central controller. The star design is most common because if one node fails, others keep working. A central unit manages and directs the data flow in a star system. When a network reaches its maximum length or number of nodes, a repeater can be added to strengthen and resend signals. A bridge separates parts of a network and only transfers data when needed, while a router connects different types of networks and chooses the best data paths. Sometimes mixed designs are used. Networks work by breaking messages into equal-sized data packets, labeling each with its destination and position in the message, then sending them to be reassembled at the other end. If a packet is damaged, it's resent. This packet switching method is very efficient for handling bursts of communication across distributed systems, though it doesn't guarantee steady real-time delivery. Networks must also define rules for how users access storage and devices, which limits total bandwidth. In client-server networks, most data and programs are stored on a central server. In peer-to-peer networks, each computer manages its own files locally. Ethernet is a type of computer network that links personal computers, printers, disk drives, and other devices using coaxial cables, twisted pairs, or optical fiber. It sends data asynchronously and includes a system for detecting and managing data collisions. Asynchronous Transfer Mode, ATM, is a high-speed network standard designed for flexible and efficient communication. It uses fast switching, variable bandwidth, and multiplexing to send audio, video, and other data at speeds of 1 gigabit per second or more. A TM is mainly used in wide area networks, WAN, and as the backbone for large local networks with many users. In traditional networks, multiple data channels are combined into one stream, and each receiver extracts its own data, which requires a lot of routing information and adds overhead. A TM works differently. It uses switching and multiplexing to create a temporary virtual channel within the available bandwidth. This channel gets just the right data rate needed, providing bandwidth on demand. Data packets, called cells, include the channel name and need far less routing information. Many users can share the same ATM channel through multiplexing while keeping data timing consistent. This allows slow and fast data to be sent together efficiently with every time slot filled, ensuring a smooth and continuous data flow, essential for real-time audio and video. A TM is sometimes called broadband ISDN. The AES 47 standard defines how to send audio over ATM channels. PCM samples can be placed into ATM cells in different ways, by time order, channel order, or as multi-channel groups. Bluetooth is an open standard that defines how devices communicate wirelessly over short distances to exchange audio and data. It uses a peer-to-peer system, meaning two devices can connect when they come within range, forming a wireless personal area network, WPAN. Bluetooth transmits and receives signals using radio waves, and because it uses very little power, it's ideal for small, battery-powered devices. It's a global standard that works across different communication systems and operates in a license-free frequency band available worldwide, with some restrictions. Bluetooth can replace cables and is widely used in phones, MP3 players, car stereos, headsets, printers, keyboards, and game controllers. When two Bluetooth devices connect, one acts as the master and the other as the slave. The master starts communication and sets the timing pattern for frequency hopping spread spectrum, FHSS, deciding when each device can send data. The slave can only send data after the master allows it. For voice, the slave sends data during its assigned time slot. Each Bluetooth device has a unique 48-bit address. A device can be a master in one connection and a slave in another. A master can talk to several active slaves and many parked slaves, those ready to connect when needed. All devices linked to one master form a piconet. When a device belongs to more than one piconet, the group of overlapping networks is called a scatternet. In a scatternet, each piconet has its own master and timing pattern, and one device may bridge them by being a master in one and a slave in another. Bluetooth devices use different power and activity modes. In active mode, a slave stays fully connected and synchronized with fast response but high power use. In sniff mode, it communicates only at specific intervals, saving some power with slower response. In hold mode, it remains connected but pauses activity for a time, using less power. In parked mode, it is inactive but still synchronized with the master through beacons, allowing very low power use. A master can control many devices by switching them between active and parked states, though only 7 can be active at once. Bluetooth also adjusts transmission power automatically. If the signal is too strong or weak, the slave asks the master to change its power level. Standard Bluetooth audio, narrowband, uses an 8 kHz sampling rate and 64 kilobits per second data rate with companding for clear voice transmission. For high-quality audio, the Advanced Audio Distribution Profile, a 2DP, is used in ACL mode for mono or stereo sound, for instance, to stream music from a phone to a car stereo. A 2DP supports up to 320 kilobits per second for mono and 512 kilobits per second for stereo, using the mandatory SBC codec, which divides sound into subbands and uses simple, efficient compression designed specifically for Bluetooth audio. More and more data that once traveled through copper wires or fiber optic cables is now sent wirelessly using radio signals. Wi-Fi is the technology used for wireless local area networks, WLAN. It creates a local network where devices like smartphones, computers, and printers can connect and communicate without cables. Wi-Fi is also used to send audio data between computers, accessories, and playback devices. Because it shares some technical features with Ethernet, Wi-Fi is sometimes called wireless Ethernet. MediaNet is an example of a fast, dedicated local network designed for multimedia. It allows many users to access content stored on central disk drives at the same time. Thank you for watching till the end. To better understand each video, make sure to watch the previous ones. Some may serve as prerequisites for the next. If you have any questions or opinions, feel free to leave a comment. Until next time, subscribe and stay curious.